In a previous video, we covered the details of molar mass. Here, we will learn how to use molar mass as a conversion factor to convert from grams to moles. And we'll use for our example a compound present in matcha green tea, theanine. But first, a quick reminder of what molar mass is. Molar mass is the mass, in grams, of 1 mole of a substance, either an element or a compound, and it has the units of grams per mole. For example, if we were to write down the molar mass for hydrogen, we see from the periodic table that the value is 1.008, and we would report that as 1.008 grams per mole hydrogen. Writing the units in the format g/mole is perfectly fine if we're simply reporting a molar mass. However, when we use molar mass as a conversion factor, we need to write it differently so that we can be sure the units cancel correctly. Our molar mass is really an equivalency, so for hydrogen, it relates 1 mole of hydrogen to grams of hydrogen. We can take each side of the equivalency and relocate it as either the numerator or denominator of the conversion factor. So we can write a conversion factor as 1 mole of hydrogen is 1.008 grams of hydrogen, or we can flip it upside down and write it as 1.008 grams of hydrogen is 1 mole of hydrogen. We don't need to memorize which format of the conversion factor to use because we'll let the given information in the problem guide us. So let's turn to our example. A 1 gram serving of matcha green tea powder contains 0.04465 grams of theanine. How many moles is this? Now I know there are a lot of atoms here in the theanine molecule, but that doesn't change the strategy. The steps are the same, no matter how simple or complicated the substance is. If we look at the units presented in the problem, we see that we are given grams and will calculate moles. The 2 units in the problem are grams and moles, and because these are the 2 units present in molar mass, this tells us that we only need 1 conversion factor, and that conversion factor is molar mass. Our first step then is to calculate molar mass. The masses of the elements are 12.011 for carbon, 1.008 for hydrogen, 14.007 for nitrogen, and 15.999 for oxygen. So we have 7 times 12.011 plus 14 times 1.008 plus 2 times 14.007 plus 3 times 15.999. Checking our sig figs, we see that all of our masses have 3 decimal places. So because this is addition, our final result will also have 3 decimal places. And so our molar mass is 174.200, and the units are grams per mole. To set up the problem, we start with what is given. 0.04465 grams of theanine. Now we're at a point where we have to write the value, the units, and the substance. It really is necessary because when we cancel units, we have to cancel the same units and the same substance. For our conversion factor, we'll write the denominator first because we know that the units and substance have to be the same as what we were given in order to cancel. So the denominator will be grams of theanine, and we write that as C7H14 N2O3 And the numerator will have units of moles of C7H14 N2O3. We then write in the appropriate values, 1 for mole and 174.200 for grams. Be really careful here not to mix up the numbers. Remember that molar mass is how many grams are in 1 mole. So one part of this conversion factor will always be 1 mole. There will never be any other value with the unit mole when we're using molar mass. We can then cancel grams of theanine, and we're left with units of moles of theanine. Checking our sig figs, we see that we have 4 sig figs in theanine. The 1 mole is exact, and the molar mass has 6 sig figs. So our final result will be rounded to 4 sig figs. So 0.04465 divided by 174.200 gives us 2.563 times 10 to the negative 4. The units are moles, and the substance is C7H14 N2O3.